Hi, this is Miss Linsmeyer, and we are in Topic 6, Lesson 7, Day 2. So we're continuing on with our geometric sequences and series, and so we are starting off with some vocab words, so have your vocab sheet out. We have a geometric series is the sum of the terms in a geometric sequence. S sub n, that's with the little n, represents the sum of a geometric sequence with n number of terms. So this will tell us at what term number, that's how much all of the previous ones added up would equal. Now, what else gets brought back is from semester 1 is sigma notation. Okay, so remember that S sub n is the same as what sigma is going to represent. Now, it will start with some kind of number, might say x equals 1 or n. It might give you any number here. Remember that this is your starting point and this is the last term number. Okay, so the sum, say, of 5, this would be 5 terms, and so that might be, right, 1 plus 3 plus 9 plus 27 plus 81. 1, 2, 3, 4, 5 terms, right? My sequence would say 1, 3, 9, 27, 81, but the sum of them, we would add them all up and get an answer. And that would be our sum. Sigma is another way to represent that. Okay? Now, we do have a shortcut because instead of typing now these 5 wouldn't take you that long to type in your calculator. But say I'm trying to find the sum of 100, right? We want to know what would be a shortcut. And so they have a formula for it. So you need to star this, put this in your notes, right? This will be given to you. However, you need to be able to apply it. I will not tell you what everything is, but you need to know how to use it. Okay, so what does this stand for? The sum of a particular number of terms. This, right, so a sub 1 is the first term. R is the ratio. And n equals the number of terms. So you just need 3 things in your to be able to find the sum of a specific number. Okay, so let's first just work with our sigma notation. So I want you to go ahead, copy this down. And so if you need to pause the video at any point, remember that's always the case. And so how do we read this? This is saying find us the sum of the first 7 terms, and here is the sequence. Okay, so we are going to expand this out first and then find the sum. So in order to find the first 7 terms, we're going to actually plug this in. So we need to find n sub 1, n sub 2, n sub 3, etc. Okay, now you can plug it in the formula, but by understanding what is happening, right, every time, you might be able to skip the formula and do the pattern of our ratio. Okay, so for our first term, what would that equal? That would be 3 times 2/3 to the 1 minus 1. Well, you would type that in your calculator, otherwise I know 1 minus 1 is 0. Anything to the 0 power is 1, and so 1 times 3, we get 3. Now we're going to take 2, we're going to plug in for n, and so we're going to get 2/3 to the first, times 3, we are going to get 2. And we're going to continue on. So 3 minus 1 is 2, 2/3 squared is 4/9. 4/9 times 3 would be 4/3. Now, your calculator is going to tell you that as well. So we are going to expand these out. We are trying to find all 7 terms. Okay, and so in our calculators, we're going to type that in. Divided by 3 raised to the 3rd. And we get 8/9. We should get 16/27, 32/81, and lastly 64/240. Okay, so this expanded out, we're going to write 3 plus 2 plus 4/3 plus 8/9 plus 16/27. Okay, so 1, 2, 3, 4, 5, 6, 7. That's how many tells. What is the sum? Now we're going to plug this right into this formula. So we need the sum of the first 7 terms is going to be, we have a sub 1, we have 3, we have r, which is 2/3, and we have n, which is 7. Those 3 things are going into this formula. So a sub 1 we have is 3, 1 minus r, which is 2/3. That is raised to the 7th. Close the parenthesis, all over 1 minus 2/3. Now here is the trick. Be careful when you're typing this in. Make sure that the 7 is on the ratio, not on the outside of this. That will change your answer. And so I'm going to type this in. And we are going to get this. Okay. So there is our sum. Here is our expanded form. Okay, I want you to pause the video and try this one. You are going to find the sum of this series. Okay. Welcome back. Let's first find our 5 terms. Should have had 1/2, 3 to the 1 minus 1 should give you 1/2. This should give you 3/2. 9/2, 27/2, and 81/2. So our sum should be 1/2 plus 3/2. Okay, then we go to our sum of the first 5 terms. We have a sub 1, which is 1/2. We have our ratio, which is 3, and we have our term numbers, which is 5. So a sub 1, 1/2, times 1 minus 3 raised to the 5th, all over 1 minus 3. And you should get your sum to be 60.5. Okay. Now, example 4. Okay, we are, oops. Okay, so the other one it will say is write the series using sigma notation. What is the sum? Okay, so here they are skipping a bunch, so we got to figure out, one, what is our sum, which we can actually, we won't be able to do because we won't know how many terms are here. So it says write it using sigma notation. Okay, so here is our series. So we know a sub 1 is -2. Okay, what we want to find, we need our r so that we can write it in the ratio. Then we need to find n so that we know what our sigma is. Okay, so first we can find our ratio by taking this -2/3 and dividing it by -2. And we should get our ratio as 1/3. Okay, and it's positive because the sign is not changing. Okay, so first off, we can write the sum. Here's our sigma notation of x starting at 1. Now, what is our sequence? Would be first term, -2. We have our ratio, and then we have n minus 1. Or x minus 1 because we're using x. Now, what we are missing is up here. We don't know how many terms this is. So, what we need to do then is to actually use the formula. And we are looking for x. Okay? So, what is this? This is our last term. We don't know what n is, but we do know that that's our last term. So we're going to write -2 over 243, and we are going to solve this. Now, anytime you have to find your n, you will always do the same thing. You're going to first divide by -2, which is the same as multiplying by 1/2. We should see that we get 1 over 243 equals 1/3 x minus 1. Now, I want you to think about this. Either we can know what this is in for how many 1/3 this is, or we can change this to log form since we have x in the exponent. Okay, so what we can go is log base 1/3 of 1 over 243 equals x minus 1. Okay, we can use change of base, and we should get log of 1 over 243 over log of 1/3. That's going to equal x minus 1. And we should get 5. And lastly, we're going to add 1. Okay, so 6. This is the term number, and so where this goes, what we just found, right, was our missing piece right here, and so here is our 6. There is our sigma notation. Okay, now that's part of it. They want us to find the sum, so we have the sum of 6 terms. We would have a sub 1, which is -2. We have r, which is 1/3, and we have n, which is 6. So -2 times 1 minus 1/3 raised to the 6th, all over 1 minus 1/3. And about -728 over 243. which negative should make sense, right? Because they are all negative. Okay, so I want you to pause the video and see if you can find how many terms are in this geometric series. Okay, here's your series. The terms is what we just did when we set it up for our equation. Okay, so you're going to need this formula. Pause the video if you need. Okay, welcome back. Let's talk about a sub n. That's 7688.7. We have a sub 1 is 200, and r is going to be 300 over 200, which is 3 over 2. So I'm going to divide by 200. I'm going to leave that as is for right now. Now this is a perfect example of I'm just going to change to log form. So log base 3/2 of that equals my x minus 1, right? Log base of equals my exponent. So change a base. And we're going to type this in. And we get 9. Add 1. And we get x equals 10. So there are 10 terms in this sequence. Okay. And so we have one last type of problem. This time we have the sum of the geometric series. We have the first term and its common ratio. How many terms are in the series? So what you have to think about is what information do we have? We now have this formula. And so let's start highlighting what we know. We know the sum. We know that the first term, so a sub 1 is 3. We know the common ratio is 5. We are looking for n. So let's plug in what we know. Okay, so we had the sum, we had a sub 1, and we had our ratio, which happens twice. Okay, so now how do we solve this? We're going to want to actually find out that that's -4. And so I'm going to multiply both sides by -4 to cancel that out. And then we're trying to get past this, so we're going to divide by 3. We are going to subtract 1. Oops, not divided by, subtract 1. And get -156.25. and we have -5 raised to the n. So in this case, we're going to divide by this -1. We can do that to make this positive so that we are able to actually take the log. So we're going to have log base 5 of 156.25 equals n. Okay, the other way, you can log both sides if you want, if you don't want to use change of base, because we're going to get there anyhow. And we get about 6. So 6 is our terms. Okay, go ahead and try this last one. Okay, welcome back. We should have how many terms are in this series. So now you are looking for, what do we have? Do we have the sum, or do we have this which says how many terms? So in this case, we're going back to a sub n, and then we have a sub 1 r raised to the n minus 1. So a sub n, 768, a sub 1, 3, r we got to figure out. So r would be 6 divided by 3, which is 2, and minus 1. We're going to divide by 3. And so we're going to take log base 2 of 256. We're going to change a base. And we get 8, add 1, and we get 9 terms. All right, this concludes the lesson 6-7, day 2.